Hello! If you ever added the same item to your list twice by accident and your code just silently let it happen, that's not a bug in your logic, that's a container choice problem. Most beginners use lists for everything, and most of the time that's work. But Python gives you three containers: lists, set, and tuples, and they each exist for a reason. Today you will learn what makes each one different, and which one to reach for so your code stays clean and doesn't surprise you. Let's dive in. We are going to compare all three containers across four things: are they ordered, can you change them, how do you assess their items, and do they allow duplicates. Once you know the answers, choosing the right container becomes obvious. List is a data container that can be changed and has an order. For example, if you have enemies in your game that should be sorted by initiative, you will use the list. The order in which enemies will appear in the list is constant, unless you sort it. Also, list can be changed, or put it more precisely, lists are mutable. Values can be appended to the end of the list. Now we have two mages in the end of the list, so items in the list may be duplicated. You can add value at the given position using insert method. Obviously, you can also remove values from the list. But what will happen if I will remove a mage? Since the enemies list contains two of them, remove method will remove the first occurrence of the mage in the list. If you need to delete a specific item, you can use the pop method. You can check if some element is in the list. Warrior is still in the enemy's list, but Archer is not in the list, since I removed them. To get the elements count in the list, you can use built-in len function. There are some other useful methods available in the list class, which you can always look up in the documentation or by using Python help function. Okay, I said that the list will keep the order unless you sort it. Obviously, you can sort it. In this case, items will be sorted in the alphabetical order, but in more complicated cases, you can specify sorting function to make your own sorting rules. And, as a special case of sorting, you can reverse the list. Cool! As you prepare and sort your data, you have to assess it somehow. The simplest case is to assess the value by its index. Note that indexing in Python containers is starting from 0. Index can be negative, so if you don't know exact list len, you can assess last element using -1 index. You are not limited to assess only one item in the list. You can make list slices. The first number is the start index, the second number is the last index. Both are optional, meaning the first index defaults to 0 and the second one is defaults to list len. Also, you can set the stride to get, for example, every second value in the slice. Last but not least, you can iterate through all of the list items using for loop. I would say iterating through the list is the main method of assessing the items, because usually you have to apply some logic or rules to all of the items in the list. Okay, we've done with the first container. List is ordered, list is mutable, you can assess list items by the index, and you can have duplicates in the list. Next to go is the set. Set is the collection of the unique unordered elements. Set is mutable, meaning we can add and remove the values. To continue with the game analogy, let's think about player equipment slots. As you may notice, set initialization is not very different from the list, with exception that for set we use curly braces. I said that set is mutable, so let's add the boots to the equipment. Two things have happened. Player is now wearing the boots and item's order has changed, since set is unordered. Let's experiment a bit and try to wear another helmet. There is still one helmet in the character equipment. Adding element that already exists in the set will not raise an error, but also will not add duplicate, since set values must be unique. Now let's try to remove a shield. It's removed as expected. But if you will try to remove it second time, you will get the error, because set is no longer contains that element. Where set shines is a check if element is in the set. This operation is way faster than the same operation if we would use the list. Fast lookups are brilliant, but sets are not only about them. Imagine, for example, you are making a quest, and player has to collect several quest items. Also, player has its own set of items. How do you know which quest item are missing? Easy, you can calculate the difference between sets. Or you can use sets intersection to answer the opposite question. What quest items the player has in the inventory? Cool, isn't it? At this point you may think that I am selling you set as a faster alternative to the list. I don't, so let's talk about the limitations. You can't use index to assess the value in the set. Python will raise an error if you try to. You can iterate through set elements, but order is not guaranteed. So let's wrap up the set container. Set is unordered. You can change the set by adding or removing elements. You can't assess value by its index, but you can check the element exists in the set. Values must be unique. Okay, done with the sets. Next step is tuple. A tuple is an ordered immutable collection. So, the main difference from the list is that once you create a tuple, you can't change it. Usually, tuples are used when you have to represent some dataset without changing it. For example, you can represent quest item coordinates as a tuple. To initialize a tuple, you would usually use parentheses, but they can be omitted. Or you can represent high score row from the database as a tuple. To assess tuple values, you will apply the same indexing and slicing logic as with the list. Also, tuples are great candidate to learn how to unpack container values. But if you try to change tuple values, you'll get an error. So, why to use tuples after all? First of all, you make a statement that data you are using is not subject to change. Second, tuples have minimal memory footprint and are faster than the lists. So, here is the tuple. Tuple has an order. Tuple is immutable. You can assess elements by an index. Tuples can have duplicated values. Okay, that's all three general purpose containers in Python. Now, as you know their pros and cons, you can choose specific container for your needs. Let's summarize it once again. Use list when you have data that is frequently changed, sorted in any way, and assessed mostly by iterating through it. Use set when elements uniqueness is important and you need frequent fast lookup. Use tuple when you have to guarantee that data is not going to be changed, and also when you need container with minimum overhead. That's it for today. I hope you enjoy the journey so far, so like the video, subscribe to the channel, and see you next time. Ciao!